Hello everyone, I am Dr. Swarnalatha, working as Assistant Professor in the Department of Computer Science and Engineering. Today's topic we are going to discuss about the binary number system. So what is a binary number system? So binary number system is a number system which uses only two digits, they are 0 and 1. The numbers in the binary number system can be formed using only the two digits 0 and 1 only. And the base of the binary number system is nothing but 2. For example, if you take this, the number here 11001. So this is a number which is represent the binary number system. It means what is the base of the binary number system? 2. Why here it is 2? Because it is using only two digits 0 and 1. Therefore, the base here is nothing but only 2. And what digits are used to form a binary number? It is using either 0 or 1 only. Therefore, this is an example for what? The binary number system. And in this binary number, you have totally 5 digits, 1, 2, 3, 4, 5. So you are having 5 digits and the base of the binary number in nothing but number system, nothing but here 2. Now, if you want the numbers from decimal to binary number system, how do you present the number 1 in the binary number system? 1. And how do you present the decimal number 2 in the binary number system? 10. And how do you present the binary number 3? The decimal number 3 in the binary number nothing but 001. So how do you represent this one is nothing but, for example, if you want to represent 5, the decimal number 5 in the binary number system, then what do you do is just divide the number 5 by 2. So 2 2s are 4 and what is the remainder here? 1. And the quotient, write down the quotient here. Next 2 1s are 2 and the remainder is nothing but here 0. And then here 2 zeros are 0 and the remainder is nothing but 1. Therefore, write down from bottom to top. Therefore, 101. So, you can write the decimal number 5 in the binary number as what? 101. So, previously and before that, you can represent zeros also. The 0 is nothing but they don't have any values in the left side of the bits here. And similarly, if you want to represent, for example, 17, the number 17 in the binary number system, then how do you present here? So, divide the 17 by what is the base of the binary number system here? 2. Therefore, then what you are going to get here? So, 2 8s are 1 and the remainder is nothing but here 1. And here 2 4s are, remainder is 0. And then 2 2s are and the remainder is 0. And here 2 1s are, the remainder is 0. And here 2 zeros are, remainder is 1. Therefore, write the numbers from bottom to top. Then what you are going to get here? 1 0 0 0 1. Therefore, you can represent the decimal number 17 in the binary number as what? 10001. Like that, you can represent any decimal number in the binary number by using this conversion formula. And like we are performing the operations on the decimal numbers like addition, subtraction, multiplication, division, even the same operations you can perform the binary numbers also. So first operation, arithmetic operation taking as what? Binary addition. So what is you have for the binary addition? You have to take what? 2 binary numbers. After adding the 2 binary numbers, what is the result you are going to get? Again, binary number only. Therefore, the result of the addition of 2 binary numbers is also again a binary number only. Now, in order to add this, you have to add digit by digit. So, for example, if you are adding 0 plus 0, then what you are going to get here? 0 and carry nothing but 0. And if you add 0 and 1, then the addition nothing but what? 1. So, 0 plus 1 is equals to 1 and 0 plus 0 equals to 0. And here the carry is 0 and here also carry is 0. Next, 1 plus 0. So, 1 and 0. So, when you add these two digits, then the result addition is 1 and the carry equals to 0. And if you want to add the two digits 1 and 1, so 1 plus 1, then the addition, the result is 0, but here the carry is equals to 1. So like that, this is a table that shows the rule for binary addition. So 0 plus 0 equals to 0 and carry is 0. And 0 plus 1 is, the addition is 1 and the carry is 0. For 1 plus 0, the addition is 1 and the carry is 0. And similarly, if you want to add two digits 1 and 1, then the addition is 0 and the carry is nothing but 1. So these are the rules for adding two binary numbers. Now, for example, you have taken two binary numbers. They are, one is 1001, the other is nothing but what? 1110. So, these are the two binary numbers and you want to add these two numbers. Then, how do you add this one? So, first, what is the number here? 10001. So, write down the first number and write down the second binary number. What is the second binary number here? 11101. So, 11101. Now, add these two numbers. So, what is, already we have seen the addition of the root 2 binary digits. What are the rules here? 0 plus 0 equals 0. Addition is 0, carry is 0. And 0 plus 1 equals to 1 and carry equals 0. And 1 plus 0 equals to 1 and carry equals to 1. And 1 plus 1 equals to 0 and here the carry is 0 and the addition is 1 and 1 plus 1 0. The addition is 0 and the carry is equals to 1 here. Now what is 1 plus 1? Is equals to 0. And what is the carry here? 1. Therefore 1 plus 1 equals 0 and here the carry is equals to 1. Then 1 plus 0 equals to 1 and 1 plus 0 is equals to 1. Therefore I don't here 1. We don't have any carry here. Then 0 plus 1 is equals to 1 and 0 plus 1 is equals to 1. And next you are having here 1 plus 1. What is 1 plus 1 equals to? 0 and carry is equals to 1. So therefore here 0 and write down the carry because this is the last digit you are adding. Write down the carry here itself. So like that you can perform the binary addition onto any binary numbers. And one more example here. You want to add 10111 to the binary number 110001. This binary number consists of 5 digits whereas this binary number consists of 6 digits here. And you want to add these two binary numbers. Then how do you add here? Write down the first binary number 10111 and similarly write down the second binary number 11001. Now add these two numbers. So what is 1 plus 1 equals to 0 and what is the carry here? 1. Then 1 plus 1 equals to 0 and here what is the carry here? 1. So 1 plus 1 equals to 0 is the addition and carry nothing but here 1 is a carry and 0 plus 0 equals to what? 0 and here I got what? Carry is equals to 1. Then 1 plus 1 is equals to 0 and the carry is what? Here 1. So 1 plus 1 equals 0 and carry is equals to 1 and 0 plus 0 equals to what? Here 0. So you got here 1 plus 1 plus 0. So then what you're doing first? 1 plus 1 0 here. So what is for 1 plus 1 now? The addition is 0. And what is the carry here? Carry equals to 1. And what is 0 plus 0 equals to here? 0. Therefore here the carry is 1 and the addition is nothing but here 0. Then 1 plus 0 is 1. There is no carry. And 1 plus 0 equals to 1 only, there is no carry. And here 1 plus 1, the addition is 0 and the carry equals to 1 here. And 1 plus 1 equals to, the addition is 0 and the carry equals to 1. Like that you can perform the binary addition on any two binary numbers. So what you are doing here? 10111. Then you are adding 11001. So 1 plus 1, 0, carry is 1. So 1 plus 1, 0 and the carry is 1. Then 1 plus 1, 0 and the carry is 1 here. So 1 plus 0 is 1 and 1 is nothing but here. Then 1 plus 0 is nothing but 1 plus 1 is 0 and the carry is 1 here. 1 plus 1 is nothing but 1, 0. Therefore, what is the answer here? 100, 100 is the answer. Next type of operation you can perform the binary numbers is nothing but subtraction. And when you subtract two binary digits or binary numbers, and the result is also again you get in terms of what? The binary number only. So these are the rules when you subtract two binary numbers. What is the rule here? So 0 minus 0 is equals to what? 0 is a subtraction result and you're not getting any borrow here. Therefore, the borrow is equals to 0 here. So this is a result and this is a borrow. Then 0 minus 1. So here for 0 minus 1, 0 is a smaller number and 1 is a bigger number. So 0 minus 1, 0. 0 minus 1, then the answer is nothing but the result is 1 and since 0 minus 1 cannot be done, you have to take the borrow from that. Therefore, here the borrow is equals to 1. Then 1 minus 0. So bigger number minus smaller number. So 1 minus 0, the subtraction is, result is 1 and there is no need of getting any borrow here. Therefore, the borrow is equals to 0 here. Then 1 minus 1. So 1 minus 1 is equals to what? The subtraction result is 0 as well as the borrow result is also 0. So when you are getting 0 subtraction and 0 as a bar in two cases. What are the two cases? When the two digits are same, nothing but 0 and 0 and 1 and 1. When these two are same, then you are getting subtraction 0 as well as a bar is also 0. So you have the different methods for binary subtraction. What are they here? The first one is subtraction of binary numbers without any borrowing, and subtraction of binary numbers with borrowing, binary subtraction using 1's complement, and binary subtraction using 2's complement. We'll see the methods one by one here. What is the first method here? The subtraction of binary numbers without any borrowing here. So for example, if you want to subtract the number 8, if you want to subtract the number 8 from this 11001. What is 110? Nothing but here in the decimal is nothing but what? 25. And what is 100? So 25 nothing but what? 11001. And what is 1000 is nothing but what? 8. You want to subtract these two. So how do you write down this 25 from this variable number? For that what you do? So for example, you are having 11001. So 2 power 0 into 1. So 2 power 0, 2 power 1, 2 square, 2 cube and 2 power 4. So 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 0 plus 2 cube into 0 plus 2 power 4 into 1. Then what is 2 power 4? 16 plus here 0 into something 0, 0 plus 0 plus 1. So 11001. So 2 power 0 into 1 plus 0 into 2 power 1 plus 0 into 2 power square plus 2 cube into 1 here. So plus 8 here. So 16 plus 8, 24 plus 1, nothing but what? 25. Like that, you can convert the binary number into what? Equivalent decimal number. Similarly, you can do the 8 also. So what is 100? So here the position is 2 power 0, the position is 2 power 1, 2 square, and here the position is 2 cube, which I already had discussed in the previous class. Then how can I write down here? 1 into 2 cube plus 0 into 2 square plus 0 into 2 power 1 plus 0 into 2 power 0. That equals to what? 8. So like that you can convert the binary number into a decimal number. Now what is the question here? You have to subtract 8 from this number 25. Nothing but 100 from the binary number 11001. So 11001 minus 100. So what is 1 minus 0 is equals to 1. So previously I have seen for 0 minus 0, 0, 0 minus 1, 1, and the borrow equals to 1, and 1 minus 0 equals to 1, and 1 minus 1 equals 0. For all these cases, the borrow is equals to here 0. For all these cases, borrow is equals to 0. Now remember this table. Now what is 1 minus 0 is equals to 1. Therefore 1 minus 0 is equals to 1. Next 0 minus 0 is equals to 0. So 0 minus 0 equals 0. Next 1 minus 1 is 0. Then 1 minus 0 equals to 1. Therefore what is the answer we got here? 1001. Now what is 25 minus 8? Nothing but what? 17 is the answer. Now if you convert this 1001 into decimal number, what is the answer? Nothing but 5. The decimal number nothing but 17. Like that you can subtract two binary numbers by using this binary subtraction rule. And second case we are taking is subtraction of the binary numbers with borrowing we are taking here. So for example, if you want to subtract the number 12 from the number 26. So this is the same thing in the binary. What is 26? Nothing but 11010. And what is 12 in the binary? That is nothing but what? 1100. Now you want to subtract these two numbers. Next, what is 0 minus 0 equals to here? 0. Then what is 1 minus 0 equals here? What? 1 here. Then here, what is 0 minus 1? Will not get. Therefore, you have to get here, borrow here. So then what is this value is equals to here 1 and here equals to 0. So 0 minus 1 will not get. Therefore, here the borrow is here nothing but here 1. And here the borrow equals to 1. Then what is 1 minus 1 is equals to 0. Therefore, what is the answer we got? 1110. Therefore, what is 26 minus 12 equals 6 minus 3 is equals to 4 and 2 minus 1 equals to 14. Therefore, the same number in the binary, this is the binary number and the number in the decimal number nothing but what? 14. Like that you can subtract the numbers with borrowing also. In third case, you are taking binary subtraction using 1's complement number. So you can subtract two numbers, binary numbers using 1's complement also. First of all, what is 1's complement? 1's complement is right by reversing every digit 0 to 1 and similarly 1 to 0 in a binary number. For example, if you have the binary number, it is a 3-digit binary number which is nothing but 110. And what is 1's complement? What is 1's complement? Each digit in this binary number you have to reverse. So 0 is replaced by what? 1 and 1 is replaced by what? 0 and 1 is replaced by what? Here 0. Therefore, what is the 1's complement of 110 equals to 001. Similarly, 100 is a number, binary number. Then what is 1's complement binary number? Then so 1's complement reverse 0 by 1 and here 1 and here 1 and replace 1 by what? 0. Therefore, this is nothing but 1's complement of the number, binary number 100. Now, we want to subtract two binary numbers using this 1's complement method. So, for this, what you have to do? First, you have to write down the 1's complement of the subtrahend number. For example, you want to subtract 1. So, from this 1001, you want to subtract. Then, what you have to do? For this subtrahend, what you have to write down what? 1's complement, you have to write it down. Next, add the 1's complement of the subtrahend with minute, you have to add it. Then, if the result has a carryover, then add that carryover in the least significant bit. If there is no carryover, then take the 1's complement of the result and the result is called as what? Negative. Now, we'll take this by an example here. What is example here? You want to subtract the number 54. We want to subtract the number 34 from the number 54. Then what is the answer you have to get here? 4 minus 4 equals 0. 5 minus 3 equals to 0. So this you have to do it in the binary numbers. Now, what is a binary number of 54? So 54 is nothing but what? 11010. So this is nothing but what? 54. And so from this number, what you want to subtract? You want to subtract the number 34. Therefore, what you have to do here? 54 is nothing but what here? 110. This is a binary equivalent number. And 34 is nothing but here? 100. We want to subtract these two numbers. Now, if you don't use a complement method, then how do you subtract here? What is 0 minus 0 equals to here? 0. Then what is 1 minus 1 equals to 0. Then what is 1 minus 0 equals to 1. And 0 minus 0 equals to what? 0. And 1 minus 0 equals to what? 1. Then what is 1 minus 1 equals to 0. Therefore, what is the answer here? 10100. But the same subtraction, if you want to perform using the 1's complement, then how do you perform? First, take the minute. What is the minute here? 110. Next, what is here subtrahend? 10010. So, for this 10010, what is the 1's complement here? 01101. How do you get the 1's complement? Just reverse 0 by 1 and 1 by 0, then you get the 1's complement. So, after writing the 1's complement subtrahend, then add this to the minute. Then what is 0 plus 1 equals to 1 and 1 plus 0 equals to 1 and 1 plus 1 equals to 0 and here the carry is 1. Then 1 plus 1 equals 0 and here the carry is 1. So 1 plus 1 is nothing but 10 and 10 plus 1 is nothing but what? 11. Therefore here the carry is 1 and 1 plus 1 equals to 0 and the carry is equals to 1. Now here if the result has a carryover, then add that carryover to the least significant bit. So here the result is having a carry. So this is called as what? The result is having a carry. Then what you have to do? So you have to add this carry to the least significant bit. Therefore 010011. So this is a actual result and this is a carry. So this carry, you add this to the LSB bit. This is nothing but what? Least significant bit. And this is called as what? Most significant bit. So you have to add this carry 1 to the least significant bit of the result. Therefore, what is 1 plus 1 equals 0 and the carry is 1. Then 1 plus 1 equals 0 and the carry is 1. Then 1 plus 0 equals to 1 and 0, 1, 0. Therefore, this is a answer. So this is nothing but what? This is called as what? Binary subtraction using 1's complement. So this what you're doing here, you are subtracting smaller number from the bigger number. Then what you're doing here, then you're getting the carry. If you subtract smaller number from the bigger number, then you're getting the carry. That carry you have to add to the subtrahend, and the result is nothing but positive result. The same thing if you want to perform like 34 minus 54. Similarly here 0, 1 here 1, 34 nothing but the binary number 100, 10 minus you want to subtract from 54. Therefore 110, 110. Nothing but you are subtracting bigger number from the smaller number. Then what you are going to get here, you will not get any carry. Then what you have to do here, if you don't get any carry, then the result answer is 1's complement of the result. Then the answer is what? 1's complement of the result. So for example, if you want to make it here, then how do you perform here? 34. So what is 34 here? 34 nothing but 100, 10. Then what is 54? For this you have to take what? 1's complement. So for this, what is 1's complement here? 0, 0, 1, 0, 0, 1. Then add these two numbers. So what you are getting here? 1, 1, 0, 1, 0, then 1. Then see here you are not getting any carry because you are subtracting bigger number from the smaller number. If you subtract from smaller number from the bigger number, you are getting the carry. That carry you are adding here. Then if you are subtracting bigger number from a smaller number, you are not getting any carry. Then how do you get the result? You have to take the 1's complement of this. What is 1's complement of this? Nothing but here 0, 1, 0, 1, 0, 0. Did you get the same? Yes. But here you have to write down the sign as what here? Negative sign. Therefore here what the sign here? Negative sign. So minus 20 is the answer. Like that you have to perform the binary subtraction using 1's complement. Next, we'll perform the binary subtraction using 2's complement. Now, what is 2's complement? Is nothing but 2's complement is equals to 1's complement of the binary number plus 1 is called as what? 2's complement. How do you get the 2's complement? First, you have to get the 1's complement of the given binary number. Then, if you add plus 1, then you are going to get the 2's complement of the number. Now, here also you are taking two cases. What are the two cases? First case is what? Subtraction of the smaller number from a larger number. Then how do you subtract? How do you perform the subtraction for the binary numbers using 2's complement? The first step is determine the 2's complement of the smaller number. So this is the first step. And second step is what? Add this number to the larger number. Then omit the carry because you are subtracting smaller number from a bigger number. Therefore, you will not get any carry. So you get the carry in the result. Previously, you got also result. You got the carry. When you are getting the carry, if you are subtracting smaller number from the bigger number, you are getting the carry here. So then what you have to here? In this case, you are adding this carry to the LSB bit using 1's complement. But in this 2's complement, what you have to do? You have to omit that carry. Don't add that carry there. Just omit the carry there. Only there is a difference between subtraction of smaller number from the larger binary number using the 2's complement. Now we'll take one example. We want to subtract 1010 from 111. So what is 1010? That is nothing but what? In the decimal number 10. So this is a binary number and this is nothing but what? Decimal number. And 111, this is a binary number and the equivalent decimal number nothing but what? 15. So this is a binary number and this is what? Decimal number. How do you get? Previously I have seen. See the carry, each digit position, then add this number. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 square into 0 plus 2 cube into 1. Then you are going to get this 10. Similar here also 2 power 0 into 1, 2 power 0 into 1 plus 2 power 1 into 1, 2 square into 1 plus 2 cube into 1. Then you are going to get what? 15. So what do you want to subtract here? 15. So from nothing but this is a larger number. You want to subtract what number? The smaller number, nothing but 10. Then what is the answer you have to get here? 5 you have to get the answer. So for this, what you have to do now? First, what is a smaller number? This is a smaller number. 1010. So for this number, what you have to do? You have to find out the 2's complement. What is 2's complement equals to 1's complement plus 1. Therefore, what is 1's complement of 1010? That is nothing but 0101 plus 1. Then what are you getting here? 010. So plus 1 equals to 1 equals to 0. 1 plus 1 equals 0 and the carry is 1. And here 1 0. So 0110. So we have finished what? The second step. After that, again these two you have to add it. So what is 1 plus 0 equals to 1? And 1 plus 1 equals 0 and the carry is 1 here. Then 1 plus 1 is 0. And 10 plus 1 equals to 1 and the carry is 1 here. 1 plus 1 is 10 and 10 plus 0 nothing but 0 and the carry is here nothing but 1. So if you get the carry nothing but you are subtracting smaller numbers from the larger number, then the answer is positive. Therefore, just omit this carry and this is a final answer. Therefore, what is this 010 in the decimal number? Nothing but what? 5. Therefore, what is 15 minus 10 equals to 5. This is what binary subtraction using 2's complement when you are subtracting smaller number from the bigger number. And with the second case we are taking here, subtraction from smaller number to the bigger number. So for example, 10 minus 15 you are doing, what is the answer you have to get here? Minus 5 you have to get the answer. Then what you have to do is, you have to take the 2's complement of the number, then add this to the subtrahend. If there is no carry, if you are subtracting 10 minus 15 nothing but bigger number from smaller number, you will not get any carry. So then what you have to do, take the answer for this answer you have to take what? 2's complement. So then the answer you have to get is what? Negative number. Now we'll take an example here. So what you take here, subtract 1010 from 100 using 2's complement. So what you are doing here? 100 minus 1010. What is 100? Nothing but here 8. And decimal, what is 100? 10. Then what is 8 minus 10 equals to what? Minus 3 is the answer. You have to get it. Now we'll see how to perform this using the 2's complement method. So first what is here? From where you are subtracting 100. So what is here? The bigger number nothing but here 1010. So for this 1010, find out the 2's complement. So how to find out the 2's complement? Take 1's complement. What is 1's complement here? 0, 1, 0, 1. So this is nothing but 1's complement plus 1, do it here. So what is plus 1? So 1 plus 1 equals 0 and carry is 1 here. 1 plus 0 equals to 1 and 1, 0. So 0, 1, 1, 0. So this is nothing but what? 2's complement of the number 1010. Now add these two numbers. Then 0 plus 0 equals to 0. 0 plus 1 equals to 1. 0 plus 1 equals 0. 1 and 1 plus 0 equals to 1. Since you are subtracting smaller number from smaller number to the bigger number, you don't get any carry because it is negative answer. Therefore, here you don't get any carry. Whereas in the previous case, you are done 15 minus 10. What is 15 minus 10? Plus 5. Therefore, you are getting the carry. Just omit that carry. In case you are subtracting bigger number from smaller number, you will not get any carry. Then what is the answer you have to write down here? Take the 2's complement of this number. What is the 2's complement of 110? How do you get here? First take the 1's complement. You want to find out what? 2's complement of this number. So first find out what? 1's complement. What is 1's complement here? 0, 0, 1. For this 1 complement, you have to add what? Plus 1. So add plus 1. Then what is 1 plus 1 equals 0? And here 1 plus 1 and the carry is 1. Then 1 plus 0 equals 1 and 0, 0. So therefore 0, 0, 1, 0. Since you are taking the result as 2's complement, as there is no carry, you have to keep a minus sign. Therefore, minus 0, 0, 1, 0 is the answer. What is minus 0, 0, 1, 0 in the binary number? Nothing but what? Minus 2. Therefore, what is 8 minus 10 is equals to minus 2. Like that, you can perform the binary subtraction using the 2's complement method. Similarly, you can perform the multiplication operation also as you performed for the decimal numbers. You can perform the multiplication operation for binary numbers also. For example, you want to multiply these two. Then what is 0 into 0 equals to 0. Then what is 0 into 1 equals 0. What is 1 into equals 0? 0. and what is 1 equals to 1 equals to 1. Therefore, these are the rules when you perform the multiplication for the binary numbers. For example, you want to multiply these two 1010 into 101. What is 1010 in the decimal? Nothing but 10. And what is 101 in the decimal? 5. Then what is 10 into 5 equals to 50. And 50 in the binary is equals to what? 110010. Now we'll see how to perform this operation. 1010 into what you got here? 101. So first multiply this 1 here. Then what you can need here? 1 into 0 is equals to 0. Then 1, 0, 1. After that 0 into 0. 0 into 1 is 0. Then 0 into 0. Then 0 into 1 is nothing but 0. Then 1 into 0, 0. Then 1 into 1, 1. 1 into 0, 0. 1 into 1, 1. Then add this 1. So then here 0 and here 1 and here 0. 1 plus 1 is nothing but what? The answer is, result is 0 and the carry is equals to 1. And 1 plus 0 is 1 and 1 plus 0 equals to 1. And here 1. Therefore, this answer here 110010. So in the binary, this is the answer. Whereas in the decimal, the value is equals to what? 50. Like that, you can perform the multiplication operation of binary numbers also. Next one is binary division. So like we perform the division operation for the decimal numbers, in the similar manner, you can perform the division operation for binary numbers also. Now, if you want to find out what 11011 divided by 11. So, what is 11011 in the decimal number? How do you calculate here? So, 2 power 0 into 1 plus 2 power 1 into 1 plus 0 into 2 square plus 1 into 2 cube plus 1 into 2 power 4. So, 16 plus 8 plus 2 plus 1. So, 24, 26, 27. And what is 11 in the decimal number? So, 11 nothing but what? 2 power 0 into 1 plus 2 power 1 into 1. So, 2 plus 1 equals to 3. Now, what do you want to divide here? You want to divide 27 divided by 3. Then, what is the quotient is equals to 9 and what is the remainder equals 0. And what is 9 equals to 1001 is in the binary number, you can represent 9 as 1001. Now, what are you doing here? 11 divided by what? 11011. So, first you are taking what? The 2 digits 11. So, this is 1 times this is going. Therefore, 11 minus 11 is equals to what? 0 here. Then, this 0 will get here. So, this cannot be gone. Therefore, here, add this 0 and get this 1 here. Then, what you get here? 0, 0, 1. So, 0, 1 will not go in 1, 1. Then, in what you are doing? By adding 0, you are getting this 1 here. Then, what you get here? 1, 1. So, 1, 1, how many times you are going to get? You are going to get what? 1 time. Therefore, 1 ones are 1 here. Therefore, the result is 0. So, this is the remainder equals to 0 and the quotient is equals to what? 1001. Nothing but here 9. And this is nothing but this 27. And this is nothing but what? 3. Like that, how you perform the operations for the decimal number system, and the same way you can perform the operations on the binary numbers also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.